In the beginning there was no space, no distance, no direction, no here and no there. There was no darkness, because darkness is still a place. There was no emptiness, because emptiness still has volume. There was no vacuum, no field, no fabric, no geometry. There was not even time for anything to be missing. There was only absolute nothingness, and yet, from this impossible state something happened. A transition, a fluctuation, a transformation so small it cannot be measured, so brief it cannot be imagined, so delicate that even the laws of physics would not exist until after it was finished. This is the moment when nothing became somewhere. Tonight, we descend into the deepest mystery of the universe, the quantum birth of space itself. Before we begin, take a slow breath. Allow your body to settle, and if you enjoy journeys like this, you can gently tap subscribe to join Theories Before Sleep for more explorations into the hidden truths of our universe. Now, let us return to the very first moment when reality opened its eyes. Before space existed, there was no stage for events to unfold, no position to assign a particle, no direction to point a vector, no dimension in which anything could stretch, rotate, vibrate, or fall. The universe was not empty. Emptiness itself had not yet been invented. There was no outside to the universe, because outside can exist only if inside exists first. There was no container, no boundary, no extent. Instead, reality was suspended in a state beyond all imagining, a state with no length, no width, no depth, no time, pure non-existence. In that primordial silence, there was no difference between one moment and the next, because moments did not yet exist. Eternity and an instant were indistinguishable. Nothing could change, because nothing could begin. Nothing could end, because nothing had ever happened. And yet within that nothingness lay the potential for everything. Potential is not a physical object. It does not have mass or energy or form, but it is real in a deeper way. The way silence holds the potential for sound, the way a blank canvas holds the potential for colour and shape, the way sleep holds the potential for dreams. In this timeless void, the quantum laws that would eventually govern existence were not yet established. And yet, strangely, their seeds were already present in the form of a fundamental truth. Nothing is not stable. The idea seems absurd. How can nothing be unstable? How can something that does not exist refuse to stay as it is? But in the quantum realm, existence and non-existence are not opposites. They are partners in an endless dance of appearance and disappearance. Even in the absence of space, a deep uncertainty was brewing, a tension in the zero state that would become the first spark of space-time. Because at the most fundamental level, the universe does not tolerate absolute emptiness. Even when stripped of matter and radiation, even when cooled to absolute zero, even when robbed of dimensions and geometry, the vacuum, if we can even call it that, seethes with possibility. In this pre-universe void, a microscopic event occurred that had no location, no center, no size, no duration. A quantum fluctuation, not in space, but of space. A tremor in the void that briefly allowed a tiny, temporary somewhere to appear where before there was only nowhere. This fluctuation did not appear inside anything. There was no container for it. Instead, the fluctuation was the container, the first boundary, the first difference, the first separation between here and not here. It was unimaginably small, far smaller than a Planck length, which itself is a trillion times smaller than the nucleus of an atom. And it lasted for a time so short that even Planck time, 1043 seconds, is a vast ocean of duration in comparison. But in that vanishingly tiny moment, the rules began to shift. The fluctuation grew, not in size, because size did not yet exist, but in definition. The boundary between possibility and actuality began to solidify, like a shape emerging from fog. This was not expansion. This was emergence. A brand new phenomenon formed, spacetime, a fabric woven from geometry, causality and potentiality. Where before events were impossible, now they could unfold. Where before directions were meaningless, now paths could be traced. Where before no position could exist, now distance could be measured. Space did not explode outward. It materialized from the inside out, like a bubble of existence inflating into a void that wasn't there to begin with. This bubble was not surrounded by emptiness. It was surrounded by non-existence, a concept so strange that the human mind can approach it only through analogy. As space began to form, it began to define itself. Every new quantum fluctuation pushed the boundary of the bubble outward. Every ripple in the forming fabric became a new region where reality could exist. Time began to tick, not smoothly, but in bursts. The universe stuttering into being one Planck instant at a time. These early instants were chaotic. Space expanded faster than light, not because anything moved through it, but because space itself was coming into existence everywhere at once. Distances stretched, directions formed, scales separated, quantum turbulence froze into structure. This was the birth cry of the cosmos, and yet, for all its violence, the process was silent, because sound requires air, and air requires atoms, and atoms would not exist for hundreds of thousands of years. The universe was born in perfect, absolute quiet. As the bubble of space-time grew, it began to cool. As it cooled, laws began to crystallize. Gravity, electromagnetism, the strong and weak forces. These laws were not imposed from outside. They emerged naturally from the shape of the growing fabric. And with them came the next miracle, the possibility of matter. Because once space exists, energy can exist. Once energy exists, particles can arise. Once particles arise, structure becomes possible. All of this traces back to that first trembling moment when nothingness refused to remain nothing, and the universe took its first breath. The first moments after space appeared were not calm. They were not orderly. They were not even recognizable as moments. Time itself was still learning how to flow, and space was still learning how to stretch without tearing. The newborn universe trembled with instability, a storm of quantum fluctuations rippling across a fabric that did not yet know what smoothness was. Imagine a sheet of water suddenly frozen mid-splash, its surface jagged, boiling, erupting with impossible shapes, and then slowly settling into something coherent. But this settling did not remove the fluctuations, it preserved them. These ripples became the seeds of every galaxy, every star, every world that would one day burn or breathe. The early universe was not a blank canvas. It was a canvas shaken, its paint splattered by the violence of pure existence emerging from nothing. As space-time expanded, the chaotic fluctuations cooled and stretched, becoming larger, slower, gentler, until they formed patterns. Tiny differences in density, ripples in the quantum fabric became the scaffolding on which all cosmic structure would rise. Some regions became slightly denser, pulling more gravity, pulling more space, pulling more future. Other regions became slightly thinner, slipping into the background like soft valleys in a cosmic landscape. These differences were unimaginably small, a trillionth of a trillionth of a change. Yet as the universe expanded, they grew into the colossal structures that stretch across hundreds of millions of light years. The first somewhere was no longer alone. It blossomed into billions of fragments of somewhere, tiny patches of space destined to become the cosmic web. But an important question remains: why did space keep expanding? Why didn't it collapse back into nothing as quickly as it appeared? Why did the newborn universe choose growth over disappearance? The answer lies in something stranger than energy, stranger than gravity, stranger even than the quantum fluctuations that stirred the void, a mysterious property of the early cosmos known as negative pressure. This force, discovered not through imagination but through mathematics and observation, did not push outward like an explosion. It pulled inward on itself in such a peculiar way that space-time responded by expanding, not slowly, not steadily, but with unrestrained ferocity. Space didn't simply grow, space inflated. In less than a heartbeat, the universe went from smaller than an atom to larger than a galaxy. Not because matter was moving outward, but because the very fabric of existence was stretching faster than light could ever travel. In this inflationary surge, quantum wrinkles became mountains. Microscopic variations in density became cosmic architecture, and woven into that first expansion was a deeper truth. Space was not merely expanding. Space was committing. It was stabilizing, solidifying, anchoring itself as a permanent feature of reality. Whatever fragile fluctuation had given birth to space-time was now locked into place. The universe had passed a threshold, a point beyond which it could no longer collapse back into nothing. Something irreversible had happened. Nothingness had lost its perfect symmetry, and once broken, it could never return to its previous state. In technical language, physicists call this spontaneous symmetry breaking. In deeper language, it was the moment when existence refused to end. But the emergence of space didn't simply allow matter to exist. It created rules that matter had to follow. Before space and time, rules were impossible. After space and time, rules became mandatory. Gravity was first, a bending of the new fabric in response to energy. Then came electromagnetism, a whisper of force that would later guide light. The strong and weak nuclear forces locked into place shortly after. These laws weren't imposed from outside. They crystallized naturally as the universe cooled and space-time settled. The fabric of reality was learning how to behave. And in this cooling and learning, something extraordinary occurred. The universe began to store memory. Not conscious memory, but structural memory. Records of the quantum ripples left over from the first moments of existence. These memories are still visible today in the cosmic microwave background, a faint ancient glow that whispers the story of the universe's birth. Every pixel of that glow is a fossil imprint of the moment when nothing became something, a snapshot of the first everywhere expanding into the first somewhere. As the universe continued to grow, space thinned. The temperature fell from infinite heat to something survivable, something stable, something predictable. The wild turbulence of the quantum birth gave way to smoother expansion. And somewhere within that expanding sea, a new phenomenon emerged: distance. For the first time, there was a difference between here and there, a difference that could be measured, a difference that allowed matter to separate, to cluster, to form. Distance gave meaning to movement. Movement gave meaning to time. Time gave meaning to cause and effect. Space was no longer just existence. It was a medium, a channel through which the universe could express itself. And yet, even as space grew vast and time gained flow, something still lingered from the original void, a kind of silence, an echo of the nothingness that came before. The universe carries this silence in every region of vacuum, in every dark corner between galaxies, in every place where matter thins and gravity sleeps. The nothingness of before is not gone. It has merely been transformed, shaped, stretched, and tamed into something the cosmos can live within. But deep below all the laws, all the matter, all the galaxies and stars, the original mystery remains. Why did the void allow itself to become a universe at all? Why did the first fluctuation occur? Why was the nothing unstable? The universe does not answer. It only expands, and space continues to grow, carrying with it the faint memory of a time when there was no time, and a place where place did not exist. As the early universe expanded and cooled, space did not simply grow, it began to organize. From a chaotic sea of quantum fluctuations, patterns emerged, not yet galaxies, not yet stars, not even atoms, but something more fundamental, the skeleton upon which the future universe would be assembled. The newborn fabric of space-time had texture, a subtle grain, like the faint ripples left behind when wind passes over water. These ripples were density variations, frozen imprints of the violent quantum storm that existed at the moment of birth. At first, they were almost meaningless. Minuscule differences in energy density spread randomly across the expanding void. But as the universe cooled, gravity began to feel these differences. Like a blind sculptor tracing the uneven surface of a stone, gravity sensed where the fabric was slightly thicker, slightly heavier, slightly more willing to collapse. These tiny imperfections became gathering points, the earliest convergences of matter, the first gravitational preferences. Nothing in the newborn universe was yet large or slow or stable enough to take advantage of these patterns. But the patterns were there, waiting. Imagine a vast field covered in grains of dust. To the eye it appears uniform, but a single gust of wind reveals hidden ridges and valleys that shape the motion of every drifting particle. Space, in these first moments, was that field. Gravity was the wind, and the dust, still only potential matter, would soon begin to gather. But this gathering did not begin with atoms. Atoms were still far too complex to exist in the hellish early heat. Instead, the universe first needed to decide how energy should behave within space. Before structure could arise, energy needed to transform into particles, and before particles could form, space needed to provide a stable environment, a geometry that would not tear apart the moment anything tried to exist within it. This requirement shaped the next dramatic shift in the history of everything, the freezing of the fundamental forces. When the universe was unimaginably hot, all forces were unified, a single, elegant interaction with no distinctions. But as the cosmos cooled, symmetry broke again. The once unified force fractured into the four we see today. Gravity became the curvature of space. Electromagnetism became the interaction that would guide photons. The strong force locked quarks into protons. The weak force governed the delicate transformations of particles. Each of these forces shaped a different layer of the newborn universe, weaving stability where chaos once ruled. Gravity pulled, electromagnetism flowed, the strong force built, the weak force refined. Suddenly, space was no longer just a backdrop. It was a stage with rules, structure, and purpose. Within this emerging order, energy began its transformation into matter, not yet atoms, not yet anything resembling the familiar, but quarks and gluons, the first building blocks of everything to come. These particles flickered into existence, bound and torn apart in an inferno of heat and motion. They clumped into protons and neutrons, only to be blasted apart again by collisions occurring at unimaginable energies. It was a universe learning how to build, failing often, succeeding rarely, but beginning to assemble the foundation of all future structure. This period, known as baryogenesis, was governed by asymmetry, the slight imbalance between matter and antimatter. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. That single extra particle in every billion is the reason anything exists today. Everything, every star, every galaxy, every planet, every whisper of light is built from the leftovers of an ancient annihilation, the ashes of a universe that nearly cancelled itself out. Had that imbalance not existed, the expansion of space would have produced nothing more than darkness filled with radiation. But because of that unimaginably tiny preference, matter survived. And where matter survived, structure could form. As soon as matter existed, space responded. Gravity pulled it toward the ripples imprinted from the early quantum storm. These ripples deepened into wells. Wells became valleys. Valleys became channels. Channels became the earliest filaments of the cosmic web. Space itself was shaping the flow of matter, and matter was shaping the flow of space. They were learning to dance. This dance produced the first large-scale architecture, the cosmic scaffolding that would one day guide galaxies into their strange, beautiful patterns. But the process was slow, so slow that billions of years would pass before the scaffolding became recognizable as the universe we see today. And yet the fate of everything was already decided in these first seconds after the birth of space. The laws were set, the structure was seeded, the expansion was underway. But one final transformation still had to occur before the universe could leave behind its violent infancy. Light had to escape. For hundreds of thousands of years, light was trapped, scattered endlessly by a dense fog of charged particles. The universe glowed, but no photon could travel freely. Space existed, matter existed, forces existed, but visibility did not. The universe was lit from within, but blind to itself. Only when the universe cooled enough for electrons to bind with nuclei did atoms form. The fog cleared. Light found open space. Photons streamed outward in every direction. The first moment of transparency, the moment the universe became visible, was the moment space finally stepped out of its birth shadow. This ancient light still travels today, stretching with the expansion of the cosmos, carrying with it a map of everything the universe learned in its earliest instant. A map etched in radiation, a fossil of existence, a message from the time when nothing became somewhere. Space had been born, but it was still fragile. The early universe was a trembling fabric, soft, uneven, easily bent by the slightest fluctuation. Its geometry was not yet smooth. It was turbulent, a sea of expanding foam shaped by quantum scars left from the moment existence began. But as the cosmos grew, a profound transformation unfolded, a shift from chaos to architecture. The quantum storm faded, the violence softened. Expansion stretched the fabric so wide that the wrinkles smoothed into gentle contours. Regions that were once cramped and boiling became vast and cool. Space was learning stability, and with stability came shape. The subtle density ripples imprinted at birth were now being amplified, not because they grew stronger, but because everything around them grew weaker. Space was thinning, matter was spreading. Gravity, once lost in the chaos, was beginning to assert itself with clarity. Where the density was slightly higher, space dipped. Where it dipped, matter gathered. Where matter gathered, the dip deepened. A self-reinforcing cycle began, a quiet feedback loop guiding the entire destiny of the universe. These dips formed the earliest gravitational wells. Not holes, not tunnels, not distortions violent enough to collapse, but gentle valleys carved into the expanding fabric. Millions of these wells existed, each one a seed, a location where, someday, galaxies would bloom. But space did not only curve inwards, it stretched outwards. Between the wells, vast empty corridors grew wider and wider, expanding faster than matter could fill them. These would become the cosmic voids, immense regions where almost nothing exists, frozen echoes of the ancient low-density areas that space-time inherited from the quantum birth. The universe was not only becoming structured, it was becoming segmented, woven into a breathtaking pattern of filaments, clusters, and hollows. A tapestry of geometry written across tens of billions of light years. Yet at this early stage, the cosmic architecture was invisible. The universe was still dark. There were no stars to illuminate the pattern, no galaxies to trace the web, no photons to reveal its presence. The scaffolding was there, but the lights had not yet turned on. Matter continued to gather in silence. Protons and electrons cooled into hydrogen atoms. Hydrogen drifted into clouds. Clouds thickened into knots. Knots spiraled into vortices. Gravity tightened its grip. The universe, once a storm of unbound particles, was now a vast ocean of hydrogen gas flowing through a network of invisible channels. And inside these channels, pressure began to build. As gas collected into the valleys of space-time, its temperature rose. Atoms collided more frequently. Friction and compression turned cold matter into glowing, unstable spheres. The first stars were forming. These stars were nothing like the stars of today. They were titanic, monsters of hydrogen, hundreds of times more massive than the sun. Their heat was unimaginable. Their lifetimes were short. Their deaths were explosive. But before they died, they performed an act that changed the universe forever. They ended the cosmic night. For the first time since the birth of space, light flooded the darkness. Photons streamed across the cosmic web, illuminating the structure that had been growing silently for hundreds of millions of years. The universe was no longer a fog of cooling matter. It had become a cosmos, a landscape of fire, shadow, and geometry. Yet light revealed something deeper. Space was not empty. Even in the darkest regions, the vacuum itself carried energy, a faint background tension, a residue of the moment when nothingness became somewhere. This vacuum energy never vanished. It stretched with the universe. It diluted but persisted. And as galaxies formed and dark matter gathered and stars ignited and structures stabilized, the vacuum energy did something unexpected. It began accelerating the expansion of space. Gravity slows expansion. Mass holds the universe together. But vacuum energy, this ancient whisper left over from the birth of existence, pushes outward. Not with force, but with negative pressure, a quiet inversion that behaves as though space itself wants to create more space. The larger the universe became, the more this energy mattered. Galaxies pulled inward, but the vacuum pulled outward. Stars clumped together, but the void widened. Matter built structure, but the fabric beneath it continued to stretch like a living thing. This tension became the defining conflict of the universe's fate. As billions of years passed, galaxies aligned along the filaments of the cosmic web. Clusters formed at the intersections, voids hollowed out between them. Superclusters grew into chains dozens of millions of light years long. The structure seeded at the moment of emergence, from the first trembling fluctuation, was now a vast lattice shaping the universe on the largest scales imaginable. But beneath all this grandeur, a deeper mystery lingered. Space was not merely a container for galaxies. It was not a stage on which matter moved. Space was active. It was dynamic, elastic, responsive, a participant in the evolution of everything. Matter told space how to curve. Space told matter how to move. Expansion told galaxies how to drift. Particles told forces how to shape themselves. Every component of reality was intertwined with every other. The universe was not a cluster of objects. The universe was a coherent whole, an enormous, interconnected organism held together by the fabric of space-time. And the question that haunted physics began to sharpen. If space can stretch, if space can bend, if space can carry energy, if space can dictate the motion of all things, then what is space? What is this thing that was born from nothing yet now defines everything? Is space a field, a substance, a geometry, a consequence of deeper laws, a projection of quantum information, a holographic boundary, a vibration, a solution, a mistake? Or is space simply the universe learning how to exist? As galaxies spun and light travelled and voids deepened and the cosmic web strengthened, these questions remained unanswered. But the universe had time, billions of years of it, to shape its own destiny. And the more we learn about how space behaves today, the more we are forced to look back toward its origin, toward the moment when something first appeared where nothing had ever been. As the cosmic web grew into its vast and intricate shape, space revealed another of its hidden abilities, one far stranger than expansion or curvature or gravity. Space could remember, not consciously, not through thought or awareness, but through structure. The very shape of space-time became a record of everything that had ever happened within it. Every fluctuation, every collapse, every ripple of energy, every burst of radiation, every gravitational interaction. They all left imprints on the geometry of the universe. These imprints are not written in matter. They are written in the fabric itself. When a massive star collapses, the surrounding space-time bends and never fully returns to its original form. When two galaxies collide, the gravitational waves they release echo across hundreds of millions of years, stretching and squeezing space-time as they pass. The vacuum, the so-called empty regions of space, is not empty. It is a library, a vast archive holding the silent memory of creation. Every particle that has ever existed has contributed to this memory. Every photon that has ever travelled has carved a faint line of influence through the cosmic fabric. We do not see these lines directly, but the universe responds to them. The cosmic web, with its filaments and voids, is not just a distribution of matter. It is the fossilized fingerprint of ancient quantum fluctuations magnified across the entire cosmos. Every structure in existence is built from the echo of the universe's first moments. Space remembers the birth of light. It remembers the chaos of recombination. It remembers the pressure waves that rippled through primordial plasma. It remembers the first stars that burned heavy elements into existence. Even the darkest voids, the vast cosmic hollows that stretch across tens of millions of light years, are memories, frozen expansions from regions of low density that date back to the very beginning. The universe is a memory field, and the deeper scientists look, the more they realize that information is not lost, not truly. Information is woven into spacetime like patterns in a tapestry. Matter can disappear, stars can die, galaxies can merge, collapse or drift into darkness. But the space they move through never forgets the imprint of their presence. Even black holes, the darkest, most extreme objects, are not allowed to erase information completely. The universe has rules, and one of the most powerful is this: information cannot be destroyed. It can be transformed, scrambled, stretched, or encoded, but never erased. This rule rewrites everything we thought we understood about the cosmos. It means that the universe behaves less like a machine and more like a computation, a vast system processing and storing information through the evolving shape of space-time. It means the birth of space was not just the birth of geometry. It was the birth of a memory system capable of preserving the entire story of existence. The quantum vacuum becomes the ledger, gravity becomes the writing tool, the cosmic web becomes the archive. In this sense, space is not passive at all. It is active, it is dynamic, it is responsive, it is expressive. It is alive in the only way a universe can be alive, as a structure that learns from itself. This is why the universe remains coherent, why galaxies form in patterns, why dark matter follows filaments, why black holes encode information, why the cosmic microwave background still shows the faint imprint of the first trembling moment of creation. The laws of physics are not imposed upon space, they emerge from the structure of space, and that structure is the memory of how the universe came to be. But memory comes with consequences. The more the universe expands, the more stretched the fabric becomes. The more stretched the fabric becomes, the more subtle the imprints grow, and the more subtle the imprints grow, the harder it is for the universe to form new structure. This is why star formation is slowing, why galaxies are drifting farther apart, why some regions of the cosmic web are thinning into emptiness. The memory of the universe is getting older, its patterns are drifting, its early energy is fading. The structures that once grew fiercely now expand lazily, like ripples on a pond long after the stone has sunk. But even as the universe ages, one thing has not changed. Space still carries the echo of the moment when nothing became somewhere. Every expansion, every galaxy born, every star ignited, every planet cooled, every black hole formed, every photon released. All of it is an unfolding consequence of that first fundamental event. From an unstable void came a trembling fluctuation. From that fluctuation came geometry. From geometry came structure. From structure came time. and from time came the long cosmic story that now unfolds around us. Yet one question remains, a question deeper than origin, deeper than structure, deeper than memory. Why can space exist at all? Why should there be a fabric capable of bending, expanding, storing information, and giving rise to forces, matter, and consciousness? Why does the void permit structure? Why does the law against nothingness exist? Why does the universe prefer being to non-being? The universe continues to evolve, but the origin remains a silent riddle. A riddle woven into space-time, a riddle preserved in the cosmic web, a riddle whispered by the vacuum energy pushing galaxies apart, a riddle left behind by the moment when existence first learned how to exist. As the universe evolved, scientists expected that space-time would become simpler, that as expansion smoothed out its earliest turbulence, the underlying laws would reveal themselves with clarity. But the opposite happened. The more calmly space began to behave on large scales, the more paradoxical its nature became on the smallest scales. Beneath the calm surface of galaxies and stars, beneath the steady curve of planetary orbits, beneath the elegant arcs described by relativity, there lies a realm that defies intuition, a realm where space is not smooth at all, a realm where time is not continuous, a realm where the very concept of geometry begins to dissolve. This is the realm of the quantum foam, the deepest layer of space-time, far smaller than atoms, far smaller than quarks, far smaller than anything the human mind is prepared to grasp. At this scale, space-time does not resemble fabric, or geometry, or even emptiness. It resembles storm, a violent fluctuating sea in which tiny bubbles of space-time flicker into existence, only to collapse almost instantly. Every bubble a microscopic universe, every collapse a tiny annihilation, every fluctuation a whisper of the moment when the real universe was born. This quantum storm never stops. It underlies everything. It is the foundation upon which all classical physics rests, a foundation that is constantly shifting beneath our feet, though we feel nothing. From this foam, the laws of physics emerge as large-scale approximations. Gravity is smooth only because we are too large to feel the turbulence beneath it. Time feels continuous only because we cannot sense the microscopic jitter that slices every moment into discrete fragments. Matter itself is not a solid thing, but a pattern stabilized by the mathematics of the vacuum, a wave trapped in a geometry that space permits. Yet for all its violence, the quantum foam behaves with remarkable consistency. It always fluctuates in the same statistical ways. It always produces particles in predictable probabilities. It always respects the symmetries of the universe. This raises a strange idea. Perhaps space behaves as it does because it must. Not because of randomness, not because of chaos, but because the deep structure of reality allows no other possibility. Maybe the laws we observe are not laws at all, but inevitable consequences of the kind of existence the universe chose in the first instant of creation. If the quantum foam determined how energy should behave, then energy determined how particles should form, particles determined how atoms should assemble, atoms determined how stars should burn, stars determined how galaxies should spiral, and galaxies determined how the cosmic web should stretch across billions of light years. Everything spreads outward from that moment when the void first fractured. Under its own instability, everything is a cascading consequence of something indescribably small, As space aged, another property emerged from the quantum foundation, a property so pervasive that it shapes every object and every distance in the universe: curvature. Not curvature caused by mass, as described by relativity, but intrinsic curvature, subtle, foundational, woven into the metric of space-time itself. Even in regions with no mass, no radiation, no matter at all, space is not perfectly flat. Its curvature reflects the hidden tension left over from the universe's birth, a memory encoded in the geometry of nothingness. This subtle curvature is what gives rise to one of the greatest mysteries in all of physics: dark energy, a pressure that is not produced by matter, not produced by fields, not produced by stars or galaxies, but by the vacuum itself. It is as though space is expanding in response to a memory it cannot forget. Just as scars on skin pull tissue outward, long after a wound has healed, the early instability of the universe continues to push space-time into greater and greater volume. The more the universe expands, the more powerful this effect becomes. Galaxies drift away from each other not because of motion, but because the space between them is stretching, driven by the vacuum's ancient tension. This expansion is not slowing, it is accelerating, and that acceleration is the echo of the moment when the void first broke. The universe remembers its first breath, and space continues to expand as though chasing the momentum of its own creation. Yet the most haunting realization is this: space does not need matter to exist. Space does not need time to exist. Space does not need anything to exist. It simply insists upon itself. Once the fabric appeared, once the symmetry of nothingness broke, space became self-perpetuating, a phenomenon that, once triggered, could not be undone. We live inside that phenomenon. We drift through its expansion, feel its curvature, obey its rules, and build our entire understanding of reality within its boundaries. But the origin remains hidden, buried not in stars or galaxies, but in the deep quantum silence beneath everything. A silence older than time, a silence more fundamental than energy, a silence that cracked just once and became a universe. Space feels natural to us. It feels obvious that reality should have a left and a right, an up and a down, a forward and a backward. It feels obvious that things should move, that distances should exist, that time should flow from one moment to the next. But none of this is obvious. None of this is necessary. None of this is guaranteed. The dimensions we take for granted are not universal truths. They are consequences of the very specific way our universe chose to exist. When the void fractured and space was born, the fabric that emerged did not simply expand. It selected a structure. It chose how many directions space could extend into. It chose whether those directions were curved or flat. It chose whether movement was continuous or discrete. It chose whether time was a dimension at all. This choice was not conscious. It was not designed or intended. It was a natural outcome of the quantum instability that created space-time. A momentary fluctuation froze into a geometry, and that geometry became the blueprint for the entire cosmos. But here is the strange part. The laws of physics only work in a universe with the exact number of dimensions we have. If space had one dimension, gravity could not form structures. If it had two, orbits would be impossible. If it had 4 or 5 or 10, atoms would collapse or fly apart before forming anything stable. 3 spatial dimensions is not just convenient, it is necessary for a universe like ours to exist. But this fact raises a deeper question. one so profound that even the greatest theories hesitate to approach it. Why did the universe choose 3? Why not 2? Why not 11? Why not a continuum of dimensions shifting and blending as the universe evolved? To answer this, we must step deeper into the quantum origin of space, into the structure that formed before matter existed, before forces crystallized, before anything had the chance to move or collide. When space-time first emerged, it did so as a field, a mathematical object filling possibility with shape. This field had to be stable. It had to be self-consistent. It had to remain coherent through expansion and cooling. Most configurations of space-time do not have this stability. Most collapse instantly, tearing themselves apart or dissolving into nothingness. Only a few geometries can survive the transition from quantum fluctuation to physical reality. And one of those geometries, the one that survived in our universe, is a 3-dimensional space paired with a single dimension of time. This configuration is dynamically stable, mathematically consistent, and capable of supporting long-term structure. But there is more. The early universe very likely contained more dimensions. Some theories suggest 10 or 11. Others propose infinite layers folded tightly upon themselves. But as the universe expanded, these extra dimensions lost stability. They curled up, rolled tightly into shapes smaller than a proton, smaller than a Planck length, hidden beneath the scale where physics becomes foam. The universe shed its unnecessary dimensions the way a newborn creature sheds an embryonic shell. What remained were the dimensions strong enough to survive an expanding cosmos, 3 of space, 1 of time. Everything else collapsed inward, sealed away in quantum compactification, beyond the reach of any experiment. We live in the residue of that collapse. 3 dimensions, not because they were chosen, but because they endured. Time, not because the universe needs it, but because without it motion cannot be defined, change cannot occur, and energy cannot flow. Time is not an external clock. It is the record of the universe's unfolding, a 4th dimension woven into space-time to prevent the cosmos from being frozen in stillness. Without time, the universe would be a sculpture. With time, the universe becomes a story. But time is not like space. It does not stretch in all directions. It does not loop back or branch or curl up in the same way. It has a direction, a flow, not because time itself demands it, but because entropy does. The arrow of time is not a property of time, but a property of change. As the universe expands, entropy increases. As entropy increases, disorder grows, complexity rises, and the future drifts further from the past. This is why time moves forward and not backward. This is why we remember yesterday but not tomorrow. This is why stars burn, galaxies form, and consciousness evolves. Time is the shadow cast by entropy as it unfolds within space. But here is where the mystery turns even deeper. Space and time may not be fundamental at all. They may not be things. They may be consequences. Emergent phenomena arising from something deeper, something more primal, something that existed before geometry, before dimensions, before the universe became somewhere. Some physicists call this deeper structure quantum information. Others call it spin networks or string configurations or causal sets or holographic states. But all theories converge on one startling idea. Space is not the stage. Space is the illusion. What is real lies beneath the surface of the space-time fabric. If this is true, if space is not fundamental, then the birth of the universe was not the birth of geometry, but the birth of information. And the expansion of space is simply the unfolding of that information into a readable physical form. Space exists because information needed a place to express itself. Matter exists because information needed structure. Time exists because information needed sequence. And the cosmos exists because information became aware of itself through complexity. We are part of that complexity, patterns of information woven into the fabric of a universe that once lived inside a quantum fluctuation. A universe that transformed the simplest instability imaginable into a reality with stars, galaxies, consciousness, and meaning. 3 dimensions were the ones that survived. Time is the river that carries memory. Space is the language that information uses to write the story of existence. But the question remains, if space and time are emergent properties, what lies beneath them? What is the true substrate of reality? What existed before the first somewhere appeared? Perfect, Yunes. Here is part 3, segment 2. Continuing seamlessly from segment 1 with the exact same dark, atmospheric, cosmic tone. This segment dives even deeper into the hidden substrate beneath space-time, the layer where geometry dissolves and information becomes the true architect of the universe. No repetition, no recap, no restart, just pure continuation, as if the documentary never stopped. Part 3, Segment 2, The Hidden Substrate Beneath Space. If space is not fundamental, then the universe must be built on something deeper, something that does not resemble distance, direction, location, or extension. Something that does not care about up or down, left or right, near or far. Something that existed before geometry crystallized, before dimensions unfolded, before the universe became a playground for matter and light. Strangely, the deeper physicists probe into this idea, the more the universe begins to resemble an organism not made of matter, but of relationships, connections, interactions, patterns, a raw network of information from which space-time emerges the way waves emerge from the motion of water. This unseen structure is not spatial, not in any sense we understand. It is a web of interactions that define how particles behave, how forces act, and how the flow of time unfolds. Some call it the quantum graph, others call it the spin network or the pre-geometric field. A few describe it as the proto-reality hidden beneath all physical laws. In this substrate there is no place. There are only connections, nodes linked by relationships, energies binding into patterns that will one day bloom into the space-time we recognize. Space is the shadow of these interactions. Time is the order in which they occur. Dimension is the directionality of how they connect. But none of these concepts are present at the base layer. They appear only when the network grows dense enough to behave like a continuous fabric. Imagine a carpet. From a distance it looks smooth and soft, a unified surface. But zoom in close enough and the fabric dissolves into tiny threads looping together in patterns. Closer still, and the threads dissolve into fibers. Closer still, and the fibers dissolve into molecules. No longer a surface, no longer a sheet. Geometry is not fundamental. It is the illusion created by countless tiny components working together in such great numbers that the mind interprets them as smooth. The same is true of space-time. At the deepest level, there is no fabric. There is only combinatorial structure, a web of yes-no relationships that encode how reality must behave when it crystallizes into physics. In this sense, the universe is not built on space. Space is built on rules, and these rules are encoded in the quantum substrate as information. The tiniest grains of existence are not particles or waves or fields. They are bits. Not bits like computer ones and zeros, but bits of physical distinction. Patterns that represent the difference between one possible universe and another. When nothing existed, there were no patterns, no states to distinguish, no information. But when the void fractured, it created difference. Difference created information. Information created connection. Connection created structure. Structure created space-time. This is why many physicists believe that information is more fundamental than matter, energy, or geometry. Information does not live inside the universe. The universe lives inside information. But if information is fundamental, then something shocking follows. The Big Bang was not the birth of space, it was the beginning of computation. The early universe was not a fireball. It was an algorithm executing its first steps, processing the initial conditions that emerged from the instability of nothingness. As the algorithm executed, it produced geometry. That geometry became space-time. Space-time created pathways for energy to flow. Energy formed particles. Particles formed atoms. Atoms formed stars. Stars forged elements. Elements formed planets. Planets spawned chemistry. Chemistry discovered life. Life discovered curiosity. Curiosity discovered physics. Physics rediscovered information. The universe is a loop that becomes aware of its own foundation. But the quantum substrate is not just a mathematical abstraction. It has physical consequences. For example, black holes, the most extreme laboratories in the universe, appear to store information on their event horizons, not inside, not lost forever, but encoded like a hologram on their surfaces. This suggests something profound. All the information inside a region of space can be represented on its boundary. This is no coincidence. It is a clue. A clue that space-time is not a volume but a projection. That somewhere is a manifestation of deeper information arranged along surfaces in ways we barely understand. This is known as the holographic principle, one of the most mind-bending ideas in theoretical physics. If it is true, then space is not fundamental. Volumetric reality is not fundamental. The universe we move through is a derived phenomenon, emerging from information encoded on surfaces of higher abstraction. We are patterns within patterns within patterns. But here lies the paradox. If the universe is holographic, if space-time is emergent, if geometry is secondary, then the quantum substrate beneath everything might be the only true reality. And that substrate has no shape, no size, no motion, no distance, no orientation, no dimension. It is structure without location, information without space, order without geometry. From such an alien foundation, the universe we know, with stars and planets and galaxies and life, is nothing short of miraculous. The cosmos is not simply large, it is deeply unlikely. A rare arrangement of pre-geometric rules that just happen to produce a stable, expanding, dimension-rich universe capable of sustaining structure for billions of years. One shift in the substrate, one change in the early computation, and we would inhabit a universe with no atoms, or no forces, or no time, or no space. Something about the first fluctuation selected this particular physics, this particular geometry, this particular reality. And that selection remains hidden, buried beneath space-time, encoded in the deep structure that preceded the birth of the cosmos. Whatever existed before the first somewhere still whispers beneath the fabric as quantum fluctuations, vacuum energy, and the strange persistence of dark energy. Space is the surface, the substrate is the truth. And that truth is older than time, older than matter, older than dimensions, older even than the universe itself. In the deep substrate beneath spacetime, before geometry existed, before the first distance was measurable, before anything could move or change, something remarkable occurred, something subtle, almost invisible, yet more important than anything that would follow. A sequence emerged, not a rhythm, not a flow, not a ticking or a beat, but a simple ordering of events, a before and an after. This ordering was the universe's first act of self-organization, and from that ordering, time was born. Time did not begin as a cosmic river carrying stars and galaxies on its current. It began as a barely perceptible distinction, a rule for how the substrate could update itself, one change after another. Before time emerged, all potential events were equally real, equally possible, equally undefined. With the birth of time, the universe acquired direction, a preference for how states evolve. This preference is known as causality. Causality is not just a rule that the universe follows, it is the rule that makes the universe possible. Without causality there can be no motion, no change, no interaction, no growth, no collapse, no existence. Even space-time itself cannot emerge without causal ordering. Just as threads cannot weave without a sequence of crossing, the substrate cannot generate geometry without a sequence of updates. But time did not suddenly appear as a smooth flow. Its earliest form was granular, a series of discrete transitions occurring at the smallest scales imaginable. What we call Planck time is the size of these transitions, the smallest meaningful interval in which the universe can change. Below this scale, time loses meaning, moments blur, causality dissolves. The familiar river of time is an illusion created by trillions of these microscopic updates, stitched together into a continuous flow. It is this continuity that allows stars to move, planets to orbit, light to travel, and life to unfold its story. But the emergence of time reveals something profound. The universe is not a static object, it is a process, a self-updating structure that evolves moment by moment, guided by the rules encoded in the substrate below, and just as space did not remain empty, time did not remain directionless. Entropy, the measure of disorder, pushed time into its familiar arrow. Not because nature prefers disorder, but because nature explores possibility. As the universe expanded, it opened up more states than it could ever explore fully. With each passing moment, there were more ways to move forward than backward. Entropy gave time its asymmetry, its flow, its inevitability. But this raises a haunting question. If the arrow of time is emergent, could it have pointed the other way? If the universe began in a state of high entropy, time would have flowed backwards, toward order, toward contraction, toward simplicity. But our universe began in a state of extraordinary smoothness, an incredibly low entropy state that has puzzled physicists for decades. Why was the universe born with so little disorder? Why did creation begin with a state so improbably special that it allowed time to choose direction? One answer suggests that the smoothness is not an accident. It is a memory, a fossil imprint of the pre-geometric substrate still echoing into the physical universe. The early cosmos reflected the simplicity of the substrate itself, a structure without dimension, without distance, without spatial complexity. As the universe matured, complexity rose, entropy rose, space became structured, time became directional. But the deep origin remains whisper quiet, a region where symmetry rules, where information flows gently, where the distinction between past and future collapses into a single abstract state. To understand this is to understand something else. We do not experience time as biology or psychology alone. We experience time because we are built from the processes that time shapes. Consciousness is a child of causality. It emerges from ordered sequences of neural patterns that depend on the universe's causal structure. Our awareness of time is the echo of the universe learning to update itself. But consciousness introduces a deeper wrinkle. It experiences time not as a physical parameter, but as a felt phenomenon, a subjective flow that seems to move independently of clocks and cosmology. Why should this be? Why should the universe create an observer capable of reflecting on the very fabric that produced it? Some physicists argue that consciousness is simply an emergent complexity, a byproduct of biochemical systems. But others propose a more radical idea. Consciousness arises from the same informational substrate that gives birth to space and time. In this view, the mind is not separate from the universe. It is the universe in one of its self-referential modes. A structure within space-time capable of interpreting space-time. A pattern emergent from rules capable of reflecting on rules. A result of causality capable of questioning causality. If space-time is emergent, then consciousness may be emergent from emergence. A higher order phenomenon born from the deep logic that governs reality itself. This perspective bridges physics and philosophy. It suggests that the universe, in creating observers, is not generating something foreign. It is revealing a deeper layer of itself. But this leads us to a final question in this segment, a question at the heart of the quantum origin of space. If space and time emerged, could they vanish? Could the universe reach a state where geometry dissolves again, where dimensions collapse, where causality unwinds, where time ceases to flow? Some theories say yes, that the universe could reach a thermal equilibrium where all differences vanish and space-time loses meaning. Others say no, that once information takes the form of geometry, it persists, forever unfolding in new configurations as long as entropy rises. But one truth remains: space is temporary, time is temporary, dimensions are temporary, matter is temporary. The substrate beneath them is the only thing truly fundamental, the only thing that predates the universe and will outlast it. Everything we call reality is a translation of that deeper language, a language spoken not in sound or symbol, but in patterns too pure for human senses to grasp. As the universe expanded and cooled, something subtle began to happen, something so unexpected that it would take humanity nearly 14 billion years to even suspect it. The universe began to store its information not inside its volume, but on its surfaces. This discovery did not come from galaxies or stars or the quiet geometry of space. It came from the darkest, most unforgiving objects in existence: black holes. When a black hole forms, matter collapses inward, crushed beyond recognition. Every particle, every atom, every bit of information is swallowed by gravity so intense that not even light can escape. It seems like the perfect place for information to vanish forever, but nature refuses to lose information. In the 1970s, physicists found something disturbing. A black hole's information is not stored inside it. It is stored on its event horizon, the surface, not the volume. This was the first crack in the illusion of three-dimensional space. If the entire content of a black hole can be encoded on its surface, then maybe the universe itself works in the same way. Maybe everything we see, every planet, every galaxy, every nebula, every moment, is holographically encoded on a distant boundary. Not a wall, not a container, not a physical surface, but a mathematical horizon defining the limits of what we can observe. This idea became known as the holographic principle. A principle so radical, so transformative, that it rewrites the very meaning of existence. If the holographic principle is true, then the universe is not a place, it is a projection. A three-dimensional experience emerging from a two-dimensional blueprint of information. Just as a hologram contains depth despite being flat, the universe contains volume despite its deepest truths existing on its boundaries. But what boundary? Where does the universe encode its information? To answer this, we must understand something equally strange. The universe has an edge. Not a physical wall, not a border you can touch, but a cosmic horizon. A distance beyond which light has not had time to reach us since the birth of the universe. Everything beyond that horizon exists, but it is forever inaccessible, a sealed region of reality we will never observe. This horizon is not static. It expands as the universe expands. It grows larger as more space comes into view, and on that shifting boundary the information of our universe may be inscribed. A cosmic film playing outward as space-time unfolds. A silent surface holding the blueprint of everything that can ever happen within the observable universe. If this is true, then reality becomes something far more subtle than our senses suggest. Objects are not in space. Objects are space. Localized expressions of information encoded on the boundary. Distance becomes an illusion. Volume becomes an illusion. Mass becomes a translation of boundary data into physical form. And consciousness, the strange internal mirror through which the universe sees itself, becomes a process emerging from holographic rules that far exceed our biological origins. But the holographic principle does not merely rewrite physics, it rewrites identity. If you are holographically encoded, if your memories, your thoughts, your sense of being are all emergent projections of deeper information, then you're not a physical body moving through space. You are a pattern, a shimmering living arrangement of cosmic information that emerges whenever the conditions of space-time call you forth, a wave in the sea of existence, temporary, beautiful, and inseparable from the ocean beneath. But why would the universe work this way? Why encode reality on a boundary? Why use holographic rules instead of simple geometry? The answer may lie in quantum gravity, the elusive theory that merges space-time with quantum mechanics. Gravity, at its deepest level, seems to behave as though the universe is trying to preserve information no matter what happens. Black holes, dark energy, expansion. They all point to a universe concerned not with objects but with data. The holographic principle is not a trick of light. It is the architecture of existence, a universe that unfolds from information. A cosmos whose boundaries are more real than its interior, a reality that is deeper than space and older than time. And if this is true, if everything we experience is encoded elsewhere, then the most haunting question remains: what is the projector? What is doing the encoding? What lies behind the hologram? If the universe truly encodes itself on a boundary, then that boundary must be more than a passive surface. It must be dynamic, constantly updating, recording, storing, and translating the information that becomes the cosmos we experience. This boundary is the cosmic horizon, a sphere centered on every observer and expanding with the universe. It is not a physical shell. It is not a wall. It is a limit, the farthest distance from which light has had enough time to reach us since the beginning of everything. Beyond that limit is the rest of the universe, vast, real, but forever inaccessible. Yet somehow the information of that inaccessible region appears to influence the interior we can see. The cosmic horizon is not a simple edge. It behaves like a living membrane, a surface through which reality is continuously encoded. Every shift in the universe, every quantum fluctuation, every gravitational ripple has an imprint on this expanding boundary, and the boundary responds, just as a holographic plate records interference patterns of light, patterns that later reconstruct a full 3D image. The cosmic horizon records the interference patterns of reality itself. Those patterns are not static images. They are sequences of information flowing outward as the universe expands, encoding the evolution of every region of space. Matter, energy, motion, curvature, all become data on the surface of this horizon. The hologram is not the illusion. The illusion is the volume. To the substrate beneath spacetime, there is no inside the universe and outside the universe. There is only information spreading across a cosmic boundary, expressing itself inward as the three-dimensional world we recognize. This might sound impossible, yet black holes force us to accept it. A black hole's mass is determined not by the space inside it, but by the area of its horizon. Double the area, and the black hole's information doubles. Not because more matter is inside, but because the surface can store more holographic data. This surface encoding is identical in form to the cosmic horizon. The universe behaves like a black hole in reverse. Information flows outward instead of inward, and the horizon expands instead of shrinks. But the principle is the same. Reality is stored on a boundary and expressed inward as geometry. What we call space is a decoding of that boundary information. Just as a hologram reconstructs a 3D shape from a flat surface, the universe reconstructs our reality from the data etched into its cosmic horizon. Every atom you see, every star in the sky, every galaxy drifting through the cosmic web, all of it is a manifestation of boundary information projected into volumetric form. But this raises a disturbing possibility. What if the universe we see is not the most fundamental version of reality? What if we are witnessing a projection of higher dimensional information compressed into a lower dimensional horizon? In some models, our universe is like the shadow of a deeper, richer realm, a place with more dimensions, more structure, more freedom than our space-time can express. Imagine a four-dimensional object casting a three-dimensional shadow. Imagine that shadow unfolding as time passes. Imagine inhabitants of that shadow believing their world is the full reality, when it is only a projection of something greater. This is the holographic principle, not a metaphor, not a poetic idea. A physical description of how quantum gravity may actually function. If true, then matter is not fundamental. Energy is not fundamental. Even space-time itself is not fundamental. The only thing truly real is the boundary information. the patterns inscribed on the cosmic horizon, and those patterns must evolve according to strict rules, rules that determine what kinds of universes can be projected, rules that specify what particles can form, how forces interact, how galaxies cluster, and how consciousness arises from matter. But something even stranger happens when we view the universe holographically. Gravity becomes an emergent phenomenon. Gravity is not a fundamental force in the holographic universe. It is the effect of information rearranging itself on the boundary. When matter moves, its boundary encoding shifts. That shift changes the curvature of the holographic projection. We interpret that curvature as gravity. This explains why gravity is so different from the other forces, why it resists quantization, why it interacts with everything, why it is so weak compared to electromagnetism or nuclear forces. Gravity is not a force. Gravity is geometry. Geometry is information. Information is the substrate. And information, unlike matter or energy, cannot be destroyed. Not by black holes, not by expansion, not by time. This means something astonishing. When the universe ends, its information will remain, encoded not in space, not in matter, not in galaxies, but in the structure of the boundary that once projected it. The hologram continues even after the image fades. But the most haunting implication is this: if the universe is a hologram, then the boundary is the true reality, and everything inside is a reflection with stars, a reflection with galaxies, a reflection with life that becomes aware of the very boundary that gives it shape. We are the universe observing its own encoding. We are the hologram becoming self-aware. We are information looking back at the surface from which we came. If the universe is a hologram, then everything we see, from the flicker of a star to the arc of a galaxy, is the expression of a deeper code. Not a digital code made of ones and zeros, but a quantum informational code so intricate that its patterns give rise to the laws of physics themselves. This code does not live inside the universe. It does not float between galaxies or hide inside black holes. It lives on the boundary, the cosmic horizon that encodes the entire structure of space-time. Every particle in existence, every quantum field, every curvature of space is a translation of this boundary code into volumetric form. The universe is a process of decoding. But what is the nature of the code itself? In its simplest description, it is a network of correlations, patterns that relate distant points on the boundary to form coherent structure inside. A ripple on the horizon becomes a particle in space. A shift in boundary encoding becomes a gravitational well. A complex interference pattern creates the illusion of a galaxy. Matter is not an object. Matter is what information looks like when projected inward, and the strength of this idea reveals itself in a remarkable consequence. When information increases, space expands. This is not metaphoric, it is physical. As new information accumulates on the cosmic horizon, the horizon grows. As the horizon grows, new space appears. As new space appears, galaxies drift apart. Expansion is not simply momentum from the Big Bang. It is the natural effect of the universe processing more and more information. A static universe would require information to stop changing. But information never stops. Quantum fluctuations never cease. Entropy never decreases. Boundaries never lose complexity. So the universe expands because it cannot stop expanding. It is not exploding outward. It is unfolding. But the most haunting insight emerges when we ask a forbidden question. If the universe relies on information, could that information malfunction? Could reality glitch? We tend to think of physical law as eternal and perfect, unchanging, absolute. But if the universe is emergent, if space-time is derived from deeper rules, then what we call laws of physics are simply patterns the cosmic code produces consistently. Nothing guarantees they cannot shift. At the quantum scale, tiny fluctuations already cause momentary distortions. Particles pop in and out of existence, fields tremble, vacuum energy flickers. If these fluctuations were to align in just the wrong way, even for a moment the emergent geometry could ripple, a glitch in the hologram. Most of these disturbances are smoothed instantly by the stability of the substrate, but theoretical models show that rare, extreme fluctuations could in principle produce localized distortions of space-time, a temporary breakdown of the emergent structure. The universe corrects itself, it always has, but the possibility that space-time could shimmer like the surface of water, momentarily unstable, is not entirely ruled out. At a deeper scale, the question turns darker. Could the hologram collapse? If the boundary stopped encoding information, space-time would begin to lose definition. Matter would dissolve into quantum uncertainty. The arrow of time would lose direction. The geometry of the universe would flatten into informational noise. Fortunately, such a collapse requires a complete halt of entropy increase, a physical impossibility as far as modern physics can tell. As long as disorder grows, as long as information flows, as long as the universe evolves, the hologram remains stable. The expansion continues, the boundary grows, the code deepens, reality persists. Yet another possibility emerges, one even more unsettling. Could the hologram rewind? If the boundary encodes all information, past and present, could it recreate earlier states? In theory, if the cosmic boundary contained a perfect record of all events, like the frame history of a cosmic film, then earlier states might be reproducible. But physics gives us a paradox. While the boundary stores information, entropy prevents exact reversal. The universe remembers everything, but not in a way that allows reconstruction. The arrow of time is encoded so deeply into the laws of thermodynamics that rewinding reality violates the statistical structure of the universe. Time can slow in deep gravity. It can stretch in acceleration. It can distort near black holes, but it cannot reverse. The cosmic code writes forward only, which brings us to the most profound question in the holographic model. If reality is encoded on the boundary, what is the boundary encoded within? Is there a higher dimension where the cosmic horizon exists as a physical object? Is the boundary itself a projection of something deeper? Is the universe nested? Hologram within hologram, layer within layer, each reality projected from a more fundamental one. Some theories hint that the boundary may reside in a higher dimensional bulk, a realm beyond our perceptual reach, where the true physics of the cosmos unfolds. In this view, our universe is the shadow of a higher dimensional universe, a reflection of deeper laws projected into our space-time. If so, then what we call existence is not the primary reality. It is the echo, the imprint, the story the boundary tells. And everything we are, every memory, every emotion, every thought is part of that story, unfolding one frame at a time on the inner surface of a horizon that grows with every breath the universe takes. In the immensity of the cosmos, beneath galaxies that drift like silent lanterns and voids that stretch deeper than imagination, we find ourselves small, fragile, and impossibly temporary. And yet, in the story of the universe, we are not out of place. We are not accidents. We are the final echoes of the laws that began long before atoms existed. Because everything we are, every memory, every heartbeat, every dream that rises in the quiet hours of night, is woven from the same information that emerged when the void first fractured into possibility. We are made of the same fabric that once did not exist. We come from a universe that wrote itself into being, from a fluctuation so small it cannot be measured, from a spark so brief it cannot be imagined, from a transition in which nothing learned how to become somewhere. And everything since that moment, stars, galaxies, planets, consciousness, is the long unfolding of that first fragile structure that rose from the quantum substrate. We are that unfolding. We are that continuation. We are the story the universe tells when information becomes aware of itself. When we look into the night sky, we're not looking outward. We are looking backward, into the memory of creation, into the shapes carved by laws older than time, into the echoes of an origin so profound it still whispers beneath every particle in existence. And when the universe ends, whether it fades into darkness, collapses into fire, or stretches into eternal cold, its information will remain, not lost, not erased, but transformed, written into the boundary that once projected us, stored in the fabric that outlives stars, preserved in patterns the universe refuses to forget. Nothing in reality is ever truly gone, it only changes form. Even we, brief sparks in the cosmic ocean, leave our imprint on the unfolding code. Every thought, every moment of awareness, every question we ask about the nature of existence becomes part of the universe understanding itself. And so, as we drift towards sleep, as our breath softens and our thoughts spread out like starlight in the dark, remember this. You are not separate from the cosmos. You're not an observer standing at a distance. You are the universe looking at itself through human eyes, a consciousness woven from space-time, a pattern written on the cosmic horizon, a fleeting, beautiful expression of information so ancient it predates time. And when your story ends, when your atoms return to silence, the universe will continue, carrying your imprint, your pattern, your moment of awareness forever forward into the endless expansion of its own existence. Because nothing is lost, not here, not in a holographic universe, not in the place where nothing became somewhere.